My name is Brenda Bell, Program Manager of the Azure Compute VM Size team. Today's agenda, I would like to walk through what are some of the new VM offerings that were recently released, what they are, and what some of the values that you might get by using them. We'll also have a quick video as well. Azure provides a solid foundation to run your core applications. So when you think about the broad category on investment for customers running business-critical workload, the three categories that come up most often are the comprehensive infrastructure that deliver choice and flexibility. We have choice ranges from Windows or Linux, Intel or AMD, with GPU accelerated from NVIDIA or AMD, single tenant or multi-tenant. As your footprint grows, your need for increased scalability with great performance will continue to be important to meet that need. Cost effectiveness and cost optimization are always key priority as well. We will talk about some of the VM offerings that were recently released and how this will contribute to some of this category. So with Azure offer infrastructure for every workload, be it a virtual machines or purpose-built bare metal, dev test application, customer-facing applications, or mission-critical production workloads like SAP. We have VM series that optimize for compute, memory, disk, or GPU-intensive workload, and this portfolio is growing constantly. For example, the AMD DAV4 general purpose or EAV4 memory-intense VM that are based on the second generation of EPYC 7452 processor. We have expanded the availability to 16 new regions. This wider deployment offers your organization the ability to span and run your application around the world. The Sono region availability will allow you to build solutions with higher availability and improve the uptime of your applications. We also have recently announced the new Intel Cascade Lake-based general purpose DV4 and memory-intensive EV4 offering. They're better performance than its previous version DV3 and EV3. We will deep dive a little bit more on this new VM offering later in the presentation. In the high-performance computing space, we recently GA'd the HP V2, which are designed to deliver leadership class performance, message passing interface, MPI, scalability, and cost efficiency for a variety of the real-world HPC workloads in CFD, FEA, weather simulation, earth science. This is powered by the AMD ROM CPU and Mellanox HDR Infinity Band Interconnect. Customer can run a single MPI job on a HP V2 at up to 36,000 cores. For our largest customers, HP V2 VM support more than 80,000 cores for a single job to deliver performance that's vital to some of the world's largest and most powerful bare metal supercomputers. With our GPU VM offering, early this year, Azure launches NVV4 VM series with the hardware partition GPU to offer affordable and right-sized GPU VMs to fit the workload requirement. Azure is actually the first public cloud to launch AMD data center GPU for VDI, graphic, and gaming workloads, giving the customer the flexibility to choose a VM with 1/8 of the GPU and scale up as needed to use 1/4, half, or full GPU. The NDV2 VM series are the current generally available scale-up and scale-out AI and HPC GPU offering, featuring a NVIDIA Tesla V100 NV-linked interconnect GPU with 32 GB of memory each and 100 gigabit per second EDR InfiniBand. These VM are ready for the most demanding machine learning models and distribute AI training workloads utilizing CUDA, TensorFlow, PyTorch, Caffe, and other frameworks that support NVIDIA Nickel 2 for distributed GPU work out of the box. However, we are also excited to review a new product currently entering preview that built upon this offering. We'll talk about that a little later. Workload built for the NDV2 should just work on our new ND A100 V4, which will offer substantially increased capability for large models. As mentioned earlier, we recently announced a new Intel V4 VM family The availability of this new general-purpose and memory-optimized Azure virtual machine based on the second generation Intel Xeon Platinum 8272 Cascade. This custom processor runs at a base speed of 2.5 GHz and can achieve all-core turbo frequency of 3.4 GHz. With the new DV4 and EV4 that surpassed the price and performance ratio of its previous V3 version, which is up to about 20% per improvement depending on the workloads. For the E-series VM sizes, it's increased the memory to 504 GB of RAM and also support Ultra SSD in a certain region. The new DV4, DSV4 or EDV4 and ESV4 virtual machine, the subscript of D indicate disk, which include a local data temporary disk. We offer 50% more storage compared to the DV3, EV3 instance, as well as better local disk IOPS for both read and write operation by using a Gen 2 VMs. These VMs are great fit for the application that need access to high-speed, low-latency local storage, including those that need temporary storage of data for temporary files and caches. We also introduced a new subfamily for the first time, the new DV4 DSV4 and EV4 ESV4 virtual machine, the new category of the virtual machine, which rely on the remote disk and do not provide a temporary local storage of the host in the VM. So we offer this size from 2 to 64 vCPU, and on the East family is up to 504 GB of RAM. This new VM size is similar to the DDSV4 and EDSV4. VM sizes which provide an improved CPU performance of up to 20% compared to the previous V3 version, depending on the workload. So as you recall, since the introduction of the Azure IaaS, every VM had a drive volume mounted that are backed by the local disk of the host, as you can see here in the D drive. Though these temp disks are not persist, that drive could be used for different purposes, like OS page file, automatically dumped when you deploy a VM with the window as a guest OS, or TempDB of the database. Some of the customer example where they use it in the automation as immediately store to copy the SAP installation bit on those volume, extract the compressed content, and then install from there. As I mentioned earlier, the new DDSV4 and EDSV4 offer up to 50% larger local storage compared to the V3 version. With the new VM that has a no local temp disk, that is DSV4 and ESV4, you can see that there's no longer temp disk. That means no D drive. And the OS page file has now moved to the OS disk that will allow you to continue to deploy your Windows image without issue. Both VM offerings still allow you to attach remote HDD and premium SSD or Ultra SSD as a remote storage option. We understand that this could be a bit confusing since the new subfamily that do not present a temp drive or resource volume are now named D or DS or E or ES, whereas the subfamily that represent the same capability of having the same local disk support as the V3 version are now named DD or DDS. Means that you're looking at matrix like this. So for DV3 that which had local disk, with the V4 version, the one that with the local disk is called DDV4. And now with DV4, it is a VM version that doesn't have the local disk. In summary, if your workload does still need a fast cache access to the local disk, then use the DDSV4 or EDSV4 version. If your workload doesn't require the fast local disk access and mostly rely on the remote disk like the dev test application or game server, then try out the DSV4 or ESV4 VM size. Now let me pass it to Rishabh, where he will do a quick demo on this new VM offering.
Hello and welcome. My name is Rishabh Verma, and I'm a PM in the Azure VM Sizes team. Through this demo, we hope to showcase what's new in Azure's D and E series V4 offerings. A quick important note regarding my terminology. Through the course of this demo, I'll refer to VMs without local disks as diskless VMs, so please remember that. In this demo, we'll launch a v4 instance of the E-Series VM from Azure Command Line Interface. We'll then launch an instance of the v4 diskless D-Series VM from Azure Portal. We'll then compare specs between a few different sizes of the D-Series family to specifically focus on spec differences between v3 sizes and the newer v4 sizes. And finally, we'll talk about some of the performance improvements with our newer v4 offerings. Let's begin with the developer-friendly method of creating Azure VMs. Here we'll create a new v4 instance of the E-Series. A simple one-line command, as showcased here, creates an E4DS v4 VM with a Windows 2019 data center image. For those who've been following Azure VM naming convention available in our documentation, the small letter D in this VM name, the E4DS v4, indicates a local disk is present in this size. After creating this VM from Azure CLI, when we check its configurations, we can see temporary storage is available, as showcased here. For customers who'd like to take advantage of the local disk in their VMs, can still do so by opting for the newer v4 disk options available in Azure's D and E series VMs. Now let's use Azure Portal to create our next instance of a diskless DB4 VM. Let's use the Create a Resource option. Upon selecting virtual machines, we'll jump into its configurations. For the purpose of this demo, we'll again use Windows Server 2019 on this VM size. Here we'll select a D4S v4 from the Select Size search option. Then we'll hit Review and Create to launch the VM. Once we launch a D4S v4 size VM with a Windows image, we can see there's no longer a local disk available in the VM's configurations, therefore implying its diskless attribute. As you may already know, the page file used to be on the local temp storage disk. However, for diskless VMs, the page file can now be found in the C drive, as shown here. Moving forward, let's do a spec comparison between v3 offerings and the new v4 offerings in the D-Series family. Specifically, let's pick the D4S v3, the D4 v3, the D4 DS v4, and the D4S v4. Narrowing down to the 4 options of the D-Series family, some of the key takeaway here are D4S v4 size, the first option here has no temporary storage. The 0 in the temp storage column again showcases its diskless attribute. Our newer v4 D-Series VM with the disk, in this example the D4 DS v4, now has 50% more temporary storage offering than its previous v3 option, which is the D4 v3 size, as you can see here. To showcase performance improvements, let's take the D4 DS v4 and let's compare it with the D4S v3 option. Using IOPS benchmark tools, we conducted a throughput comparison between these sizes, both which have a 4V CPU and belong to the D-Series family. There is a significant increase in disk throughput with the newer v4 offerings. In this particular test case, we found an increase in write IOPS of about 26% in the v4 offering. Finally, to measure CPU performance improvements, we ran the Geekbench 5 benchmark tool among these sizes. While there is a gain in CPU performance of about 20% with the newer v4 offerings, in this 4V CPU size, we found an average increase of about 14%. Thank you for watching this demo. We hope you found this demo informative and useful.
Thank you, Rashad, for the demo. Next, we would like to talk about the scale and performance. Application performance matters. For some application, it's what makes happy customers and grow the business. Others just want functions without a certain level of performance. Many factors can affect the performance of your application, and we continually improve the performance of the underlying infrastructure and the VM that we offer. Performance can also mean raising the limit of what's possible on a VM. We are announcing the public preview of NVIDIA T4 GPU-based NCAS T4 v3. Optimizing for machine learning inference workload. The new VM series offer better cost per performance ratio for inference workload compared to the existing NCV1, NVIDIA K80 GPU, or NCV3, NVIDIA V100 GPU skilled on Azure. Customer can also take advantage of the dedicated RT cores for real-time ray tracing in the T4 GPU to run graphic application. These are some of the specs of the new VM offering. Initial preview is in West US 2, with more regions planning in the coming month. Our high-performance offering have always been about pushing the limit of what's possible for our customer using the latest silicon at the greater scale. With computationally demanding natural language model at the forefront of the AI today, we're excited to review our next generation scale-up and scale-out GPU VM for AI and HPC. The ND-A100 V4 VM series start with a single VM and 8 NVIDIA Ampere A100 GPUs. But just like the human brain is composed of interconnected neurons, our ND-A100 V4-based cluster can scale up to thousands of GPUs. Each individual GPU is provided with its own dedicated topology-agnostic 200 gigabit InfiniBand connection for 1.6 terabit of clustering connectivity per VMs. Put another way, this means GPU to GPU bandwidth in a large clusters 16x higher than any other public cloud offering, harnesses transparently through standard multi-GPU programming library like NVIDIA Nickel 2, and backed by all new Azure Engineering AMD roamed PCIe Gen 4 powered platform. Most customers will see the immediately boost of 2 to 3x compute performance over the previous generation of system based on NVIDIA V100 GPU with no engineering work. The ND-A100 V4 is the next generation of standard-oriented AI supercomputer, available on demand at scale in the cloud. Limited private preview is available now, with an expanded availability public preview coming soon. The last category that we will talk about is cost effectiveness. Especially in the early stage of the cloud adoption journey, we see customers being very focused on cost as they shift from a CapEx to an OpEx model. Our approach to cost effectiveness is centered around flexibility of consumption model and pricing advantage options available on Azure. First off, we offer Azure reservation 1 or 3 years term. We can reduce the cloud consumption cost significantly, up to 72%, compared to the pay-as-you-go price. With 1 year or 3 years term on Windows or Linux VMs, when you combine the cost saving gain from the Azure RI with the added value of the Azure hybrid benefit, you can save up to 80%. Azure Spot VMs, which give you access to unused Azure compute capacity at a deep discount of up to 90% to one workload that are non-time critical and can handle interruption, batch processing jobs, dev test environment, rendering, and more. This VM may be evicted within 30 seconds of notice if Azure needs the capacity. Both Azure Reservation and Spot VM options are available for any of the new VM offering that we have mentioned earlier, like HB-V2, AMD V4, and Intel V4 VMs sizes. Your customer will be able to take advantage of this pricing option with our latest VM offering. For example, some database workload like SQL Server or Oracle require high memory storage and I/O bandwidth, but not a high core count. Many database workloads are not CPU intensive. Azure offers certain VM size where you can constrain the VM vCPU count to reduce the cost of the software licensing, while maintaining the same memory and storage and I/O bandwidth. The vCPU count can be constrained to 1/2 or 1/4 of the original VM size. These new VM sizes have a suffix that specified the number of active vCPU to make them easier for you to identify. For example, the current VM sizes with the standard E32 DSV4 come with 32 vCPU, 256 GB memory, and temp disk with 1200 GB, with the spec of the IOPS identified here. The new VM sizes on standard E32-ADS v4 or -16DS v4 come with the 16 active or 8 active vCPU rather than the 32 as identified here, while maintaining the rest of the spec of the standard E32 v4 for memory, storage, and I/O bandwidth. These constrained core sizes are now available on the new VM offering for MSV2, ESV4, EDSV4, and for EASV4 coming later on in the year. The licensing fee charged for the SQL Server or Oracle are constrained to the new vCPU count. As you can see, with the approximately 14K licensing cost per active vCPU, the constrained core size can result in 50% or 75% saving because of the reduced active vCPU core count from 32 vCPU to 16 vCPU or 8 vCPU. These new VM sizes allow customer workload to use the same memory, storage, and I/O bandwidth with optimizing the software licensing cost. Azure is steadily reducing the price per performance rate for the SAP workload. We know that SAP is the core of many of your business process and is a mission-critical application for your enterprise. SAP introduced their own measurements and sizing matrix called SAPs, where 100 SAP is equal to 2,000 order lines item processed per hour. What I mean is that the higher the SAP is, the better it is. So with the latest SAP HANA certified EDSV4 VMs, it will allow you to lower your cost to run your SAP business. The smaller memory VMs, as you can see in the chart, it has up to 50% reduction compared to the older VM families to achieve the same SAP numbers. For the larger memory VM sizes, it is up to about 75% of the cost saving compared to the older VM families. So last year, we have announced the DASV4 and EASV4 VM offering. This virtual machine featured the AMD 2.35 GHz EPYC 7452 second generation processor. DAV4 VM offer up to the 96 vCPU with 384 GB of RAM, while EAV4 VMs with up to 96 vCPU with 672 GB of RAM. Both with Azure Compute Unit ACU 230 to 260. This new DASV4 and EASV4 virtual machine family are SAP NetWeaver certified VM. The increased performance of this VM family provide a low price to performance ratio, driving down the total cost of ownership. With the highest CPU performance, that is with ACU of 230 to 260, D64ASV4 and E64ASV4 fill the gap in performance portfolio that require more expensive solutions before. Great business process throughput on a single vCPU accelerate SAP application side processing. Benchmark can often be a useful tool for assessing your cloud option. It is important, though, to ask if those benchmarks were conducted by independent third party and whether they use today industry standard methods. The image here shows the performance per price performance comparison from the February 2020 GigaOM performance benchmark blog post. An independent study by GigaOM compares SQL Server on Azure Virtual Machine to AWS EC2 using a field test delivered from the industry standard TPCE benchmark. GigaOM found that Azure was up to 3.6 times faster and 84% cheaper than the AWS that using Azure hybrid benefits and 3 years reserve instance. This result continued to demonstrate that SQL Server runs best on Azure. Here are some of the actual resources to learn more about our offering. Thank you for hanging out with us today to get a quick update on what we have in our list of VM offering, and hope this has been helpful, and thank you for watching.